Alright, so equation yes we let me just get this down. So question yes we are asked to evaluate this okay. Actually we've also been given the path, or let me say the contour of integration, which is z modulus is equal to 3 over 4. So we are evaluating this in the region z modulus is then z modulus is equals to what?
3 over 4.
3 over 4. Okay, so number what we want to do is we want to get rid of these fractions that are down here, but we don't want to change the meaning of the statement again, as we said. So we'll introduce a 2 on top and a 2 at the bottom, because we've not changed anything. This and that can cancel out like that. So number what we are going to have now is we're going to have integral along C of what are we going to have on top?
6 minus 10z.
Then at the bottom
Going to have 2z cubed plus 5z squared plus z minus 2
dz. Right. So now remember, if you remember what we were doing on this should be, how many poles is it going to have? 3, because the highest power of the denominator is 3. So here what you should do is you should get this in the form f of z, then punch power z minus a times z minus b times z minus c dz. So this is the form that you're targeting this for. Okay. So how are you going to find a, b and c? How you're going to do that is you're going to solve this equation at the bottom. Right? You equate this to 0 just like you did like you do with 2z to the power 3 plus 5z to the power 2 plus z minus 2 equals to 0. So now here we need to solve for z. How are we going to solve for z? How are we going to solve for z?
2z to give us 0.
Okay. Achan, Wekshenpo.
We're going to find the number which would be substituting 2z to give us 0.
Okay. So we're going to find the first number that satisfies this equation. Right? What number can you replace here, here, here? That will give you 0. What number is that?
So we try -1.
So what you do is the numbers you look from these. If to find that number, you look from the factors of this number. What numbers can go into that number? What numbers can go into 2? We have plus or minus 1, plus or minus 2. So it is from these that you are going to try. You start positive 1. When you get positive 1 in here, is it giving you 0?
No.
If you try negative 1, when you try negative 1 here, is it giving you 0?
Yes.
Okay, let's see if z is equals to, so this is called trying an error. Try an error. Z is equals to -1. It will be 2 to the power -1 to the power 3 plus 5 -1 plus -1 minus 2 equals to 0. Is this side giving you 0? So this would be -2 plus 5, which is positive 3, right? Then positive 3 minus 3 is 0. So the first factor you found is z is equals to -1. So that is your first factor. In other words, you found the first a here. Now you need to find b and c. Are you following? So now to find b and c, you're going to use whichever method that you know how to use. For the long division, the first factor that you find, you transpose the factor this side, so that you are going to have z what? Z plus 1. Then you divide this into this equation, which is 2z cubed plus 5z squared plus z minus 2. Okay, let me just move this away. Okay, like that. So now you say z this divided by z, or z into this. What are we going to have? Right. Then you say this times everything here.
2z cubed plus 2z squared.
Then here you're going to say minus everything here. Then you say like that. Then you say this minus this. Okay, not monati. Not monat e yarachita sub e minus e yarachita subtract e minus e parasharashana hapo
3z squared.
3z squared. If you want, you can drop these, which is plus z. You can also drop the 2, negative 2i. Then from here, what you do is now you do the same thing. You say z into that. What are you going to have?
3
Plus 3z. Okay, then you say 3z times this. 3z squared
plus 3z
plus 3z. Kwapwa. Then you say minus again. So again you say this minus this,
0
this minus this,
negative 2z.
negative 2z. You also drop this constant, which is negative 2. Again, the cycle continues. You say this into that, negative 2. Then you say this times everything here,
2z
minus 2. When you subtract these two, what are you going to have? 0. So now what we've done here is we've found the factor z plus 1 times 2z squared plus 3z minus 2. This, the multiplication of these two will give you that. Okay, and you just say this is equals to 0. Then you say, in other words, z plus 1 is equals to 0, and 2z squared plus 3z minus 2 is also equal to 0. Now here you can solve for z here. You can use whichever method. Which method are we going to use? You can use product factor sum. So what is we're going to say 2z squared. Then what are we going to put here?
We are going to put z minus. We are going to put z minus z.
Z minus z.
I mean minus z. Sum 11 plus 3, product 11 negative 4. So two values, yes, 1 now 4, negative 1 4.
So negative z plus 4z minus 2 is equals to 0. And the key here is that when you add this and this, it should give you that, right? So now that is the product sum, or if you want, you can use the quadratic formula to solve for z here. you still get the same answers, right? So this is z. You factor out here, you're going to factor out 2z, right? When you factor out 2z, what are you going to remain with?
Z, eh?
So an emphasis here, you also factor out the coefficient of make sure that the coefficient is 1, right? So you factor out 2z, then what are you going to have?
I'm going to have Z
Mhm.
minus,
Mhm.
which is
1 over 2, right? Because the key is, when you distribute this, it should get you back to that, right? Then here, what are we factoring out again?
factoring out 2.
So we have 4 here. We want the coefficient of z to be 1. Always make sure that the coefficient of whatever variable is 1. So here we're also factoring out what?
4.
4. So that this and this should be uniform, right? So you factor out 4, what are we going to remain with? Z minus what? 1 over 2 goes to 0. Because, yeah. So when you distribute this and this, this and this, you should get you back to that, right? So now we also factor out this and that. So meaning that we're going to have 2z plus 4 equals to 0, and z minus half is equals to 0. Here z will be equals to what? Negative what? Negative 2. Here z will be equals to positive 2. Then you found your factors, all your factors. The first factor was z is equals to what?
Z is equals to negative 1.
So you have all your 3 factors, right? So now you just, so you have your you have your 3 factors here. So let me just get rid of this. You have your 3 factors, so you can, your f of z is this on top here. You just say integral of 6 minus 10z divided by z minus, what is your a?
Z plus 1.
So it will be plus 1, right? Because the a is negative, right? So it will be plus 1, right? So it will be z plus 1 multiplied by your b is z minus 2, so negative 2 times this negative to be z plus 2. Then the other one would be z, it would be what?
Z down.
Z minus half, right? Z minus half, then z. So now once you have it in this form, it is simplified. Okay? It is simplified. Once you have it in this form now, what you just need to do is you say, you write each of these pores at the bottom, right? The pores will take turns to be at the bottom, right? So it will be, maybe you start with 6. That is when using the Cauchy's integral formula. You can use residue theorem to integrate. Then you say z minus half dz plus. So each of these pores will take turns to be at the bottom, right? So plus the other one, those that have written, so plus the integral along C of what? 6 minus 10z all over what? Z plus 1 times
Z
minus half, then divide by
Z plus 2
z plus 2
Z
dz, then one more 10 z divided by
Z minus 1 over 2
mhm,
is Z plus 2 over
mhm.
Z plus 1 dz.
Quite interesting.
So now remember, so now from here it's just simple. You know that if you have integral according to Cauchy's formula, if you have integral of f of z on top, then z minus z naught dz, this is just equals to 2 pi I f of what? F of z naught. Okay. Now this z naught should be inside the region of integration. Remember what was our region of integration? 3 over 4. Okay. Now when we look at this and that, which one is inside this region of integration? So if I were to give a simple sketch, if I were to sketch okay, if I were to sketch this, that would be centered at 0, 0. Let's do it a simple sketch. It will be centered at 0, 0. What is 3 over 2?
That is 0
0 point
0.75.
75. No, who's 0.75? So among these, which one is inside here? Is this one inside here?
Which one?
This one?
Yes.
Okay, so this one is inside, so we'll use it. Is this one inside? No, so we don't use this one. Is this one inside? No?
That is 1.
One is outside,
Outside.
0.75. So this one and this one will not use them. This will give us 0 according to Cauchy's theorem, right? Yeah, so we're just using this one, right? We're just using this one, so we're saying according to this formula, the top part is your f of z, right? So you say 2 pi I, you write your f of z, which is the top part here, which is 6 minus 10 z all over z plus 1 times z plus 2. Then you're replacing in your z naught. Your z naught will get it by equating this to 0, right? So equating this to 0, what are you going to have for your z naught?
1/2.
Is it half or negative half? Just half, right? Okay, like that. Then now you can replace. So now we have 2 pi I, then integral of 6 minus 10 times half, divide by half plus 1, then half plus 2. So when we simplify that, what are we having?
We are having on top. On top we have 1.
1 all over at the bottom.
Now 3 over 2.
Huh?
For the first part, 1 over 2 plus 1, you have 3 over 2.
3 over 2 times
Is it 15 over 2?
5 over 2. So, okay.
Yeah, right, I don't know. Is it
3
going to
over 2 plus
Over 2.
4 over 4?
Plus 4 plus 1, 5.
Yeah, over 4. 15 over 4. Is it like that? You say
15 over 4. Okay.
Nifin? Okay, so that is what you're going to have there. So now because of the inverse, you can flip it. So this is 2 pi I times 4 over 15, which just gives you 8 pi I over 14 as your final answer. So that is how you work this one out. So my exam, you just need to be very conscious, right? So remember where we started. We started looking at, sometimes they'll just give you in this form where you will no need, there will be no need for you to introduce the 2z, right? So it'll just be in this form. So you just find the factors of this by equating this to 0, which we did. We found the factors here. We use long division, find the factors, then we replace the factors there. Then from there we separate with each factor taking a 10 to be the denominator, like this. Then from there you check which of the factors are inside the region of integration. Only those that are inside will be used. Those that are outside, they are zeros. So, and for us it was only this one that was inside. Then we used it using the formula right here, Cauchy's formula. If you're integrating f of z over z minus z naught dz, forgot the dz there, dz is equals to 2 pi I f of z naught. Where there is f of z, you're replacing your z naught. How you get your z naught? You equate this to 0. So our f of z was this on top here, which we replace here. Then our z naught was half from here. We replaced and simplified, which gave us that. So that is how we're supposed to do that one.
Yes.